All right, howdy.
Howdy.
Wow. All right, cool. All right, so welcome to the first kind of Makeathon, Hackathon prep. This is the basics for Arduino, intro to Arduino. So today we're going to be going over the basics of like what is an Arduino, what can it be used for, why it's different from like a Raspberry Pi if you've heard of those. Kind of go into setting up the IDE, Integrated Development Environment. It's like where you code. And then running a simple program on the Arduino. And that's going to be it for today. So let's get started. So first off, we are TAMUmake. What are we? We are a Make community here. We are part of IEEE. And what is a hackathon? So for those who don't know, a hackathon is basically where you have 24 hours or 48. Ours is 24, to where you create a proof of concept device. And it can be really anything as long as it proves a point, like, hey, this is possible. It might not be to commercial standards or something that you would buy off the shelf. It's like, well, it's a great product, but it just proves like, hey, this is something that can be done with enough time and effort. And you would use things like Arduinos, Raspberry Pi, sensors, hardware, stuff like that to get that accomplished. And at our hackathon, which you shall come to, there will be food, prizes, and a bunch of other things going on. So, comes that. So diving right in. So, Arduino versus Raspberry Pi. Who has heard of either of these? Okay, who has heard of, for those out there, who has heard of Raspberry Pis? Who has heard of Arduinos again? Okay, so basically the main difference between the two is Arduino is hardware, Raspberry Pi is software. And that's a very, very broad generalization of it. But you can kind of think of it like that. So an Arduino is sensor / input-output based. That means that they're really good for hooking up sensors and modules to it. So if you want to, make a weather station, so you can basically record the temperature, humidity, and pressure, and then do something to output that. Arduino is very, very good at doing that. It doesn't have any operating systems. So what that means is it's not like a computer where you boot it up and then you program into it. It's you program on your computer, then you upload that code to the Arduino and it just runs it. You have to do all the modifications on your computer and then upload it to the Arduino if you want to make any modifications. It's kind of like, I call it grab and go, because you can just upload and then take your Arduino and it will save the code on it. But you can't really work with the Arduino directly. It's programming with C/C++. Who here is familiar with any type of programming? Okay, yeah, so it's not really C++, but it's C++ based. So if you understand any type of like C, C++, C#, Java, anything like that, you'll be fine. Syntax is pretty simple. And it's relatively fast in terms of like having an idea to making a proof of concept. So unlike, I guess the word would be like commercial devices where it's like you need to know exactly what this does and then exactly what that does. In Arduino, you can kind of put a bunch of things together and be like, hey, I wonder if this works. Test it. No, that really doesn't. Okay. Go back, change one thing. Okay, that works really well. How can I make that do that but better? It's kind of just very quick kind of proof of concept. Now, Raspberry Pis. We're not going to cover these in the physical workshops. Those are going to be handled by our counterparts, the online workshops. So YouTube channel, TAMUmake. If you want to learn anything about Raspberry Pis and kind of making things web-based, that's them. But to kind of sum up what they are, Raspberry Pis are used a lot for like web and server-based things. So if you want to, when something happens or when a button is pushed, send a text message or an email or a Twitter post or an Instagram post, you can do that with the Raspberry Pi because it's a computer. The Arduino is like a microcontroller. It's it does what it's told. But a Raspberry Pi is like an actual mini computer. It's got a GPU, as powerless as it is. It's got a CPU. It's got memory, stuff like that. It runs on Linux, so that's pretty close to Mac, but better. It's not Windows or Mac, but it's kind of like Mac. So if you worked with Mac, Linux will be pretty close. Windows, it'll be somewhat easy as well. That's the short way of explaining it. Yeah, to do a lot. Yeah, I did. Uh-oh. All right. Okay. So basically, to do anything though major though, you need Linux. You need to know Linux commands. Those are again going to be covered by our virtual workshop fellows, the YouTube channel. It's slower to like have an idea and then make it into an actual project because it's a little bit more knowledge intensive. Like you need to know more about how the systems will interact and work to make it actually work. And then yeah, it's going to be covered by online workshops. So what can we do with Arduino? Well, y'all are getting a sneak peek at this year's costume for me. So this is, who here knows Daft Punk, by the way? Yeah, good. So the actual hardware of this, I 3D printed. So the actual hardware is 3D printed, and I made this all myself, to what I could, and it runs off an Arduino. Now, cool thing about this is that Arduino has a lot of modules, which means you can add a lot of things to an Arduino and it will still work. Now, yep. So, that one. All right, so I need a group consensus. 1, 2, or 3. So
why don't you show us all 3?
1. Okay, so number 1 is the. Oh, okay, yeah. So the wiring does have a hardware issue where it kind of wants someone to be inside the helmet for it to work. So yeah, I'm just gonna have to do that. And then number 2. Give it a second. It's just because the way I programmed it. So right now this is Bluetooth. I'm running this from my phone, and I'm sending commands to this helmet with Bluetooth through an Arduino, which is then running a program that turns the lights on based on my commands. And the coolest thing is, let's do volume array. So I need the room to shout. 3, 2, 1. Ah! It reacts to the volume because I have a volume sensor also attached. Yeah, okay. And the rest is basically just hardware. Yeah, that's all Arduino. There's nothing that's ridiculously overly complicated. There is some complicated code with the Bluetooth because it's Bluetooth and Bluetooth, but overall, it's not that hard when you kind of understand the concepts. And that's what's great about Arduino. So you can take concepts of like, okay, so I got Bluetooth, I got LEDs, I got sound, I want to connect all 3 with an Arduino. And if I send one command from Bluetooth, it does one thing to the lights. If I send another command, it connects the lights with the sound. That's basically what you can do a lot with Arduino. Yeah, so like I said earlier, weather stations, that's a pretty common beginner's project because you can get a small module about that big, measures temperature, pressure, humidity, stuff like that. Yeah, that's kind of just an idea of what you can do. If you look up, Arduino project on YouTube, you'll find things like music machines where it's like it automatically plays like I can't pronounce it, xylophone. There we go. based on something that they input, or it will, dispense, drinks, like a drink dispenser. Like you can press a button and it will, give you Coke, or press another button and it'll give you Fanta. I'm a Coke guy. So installing the IDE. So right now we're going to be going over to y'all's computers. So if you have computers, get them out, please. So what we're going to be installing is the Integrated Development Environment, so IDE. So this is where you code for Arduino. We don't need those quite yet. Justin, we don't need them. Our album's hurt. They hurt longer. We don't really need them right now. Alright, so if everyone could go to arduino.cc. Okay, so who has Arduino already installed? Oh wow. Really? What class? Really? Y'all use Arduinos? That's nice. Alright, so the better question, who doesn't have it installed? Okay, cool. So everyone else, hang tight. Thank you. And those two, I'm just gonna go. And so basically what you want to do is go to arduino.cc, find the download for your OS, so both the all Windows, that's good. And download it. Alright, cool. Alright, so does everyone have their IDE open? Alright, cool. So, welcome to your main workspace. Don't step in that. Bad idea. Okay, so welcome to your main. I cannot speak. Wow. Welcome to your main workspace. This is where you do all your coding, and this is where you upload and kind of talk to the Arduino. It's also where you can look at output from the Arduino when you're testing things. So it's like serial. That's just kind of the data connection between the Arduino and your computer. We'll talk about that later. So you have two main commands that should show up at least. Void setup and void loop. Void setup is used for one-time setup items. So like setting the baud rate, which is basically the data connection speed-esque. Easiest way to explain that. If you want to declare variables that you will use later in your program, void setup, not the worst place to put them. There are better places, but it's not bad, especially for beginner programs. Things like that. One-time setup. So like for my Bluetooth helmet, sending a certain command to the Bluetooth module to tell it to, send out a connection signal. I have to do that in the setup because I only want to do it once. I need it to do it. And then you have void loop. This is for the repeating item. So this will be your main body of code. So things like that would be like making a light blink, waiting for a button to be pushed. Every 5 minutes, print out the temperature that my module says, or, if these two wires touch, turn on the buzzer. Stuff like that. You can do all those things. So, does everyone have an Arduino? Like Arduino kit or Arduino with them? Alright. Yeah, the Arduino kit, yeah. I'm saying right now. Yeah. Alright, so everyone connect the Arduino with the wire and then the wire to the computer. Alright? Also, please put everything back in the case where you found it, but go ham with it. Seriously? That's just sad. This is why you don't use Mac, ladies and gentlemen. Okay, Just share with like the partner for that one. Yeah. Blue wire.
Do we need to use the power supply module?
No. So the blue cable will automatically provide power to the Arduino, so you only need the blue wire and the Arduino itself. Okay. Alright, does everyone have theirs connected? Alright, cool. So we're gonna load our first program. So what you're gonna do is go up into the tab called File, and then from there, go to the sub-tab that says Examples, and go to Basics and then Blink, and then click on that. And it should open a new window, right? Is everyone there? So just so I don't lose this, I'm just going to take a look at yours. Yep. Okay, cool.
Question.
Yes.
What board is this?
Oh, we're gonna get there. Okay, so I'm gonna get there in a second. That's literally the next thing.
It's just
Yeah.
So
So
it's all one.
yeah. So all right. So for setting up the actual outputting to the Arduino, right? Under Tools, you're gonna want to set two things. First, board. Right now, we're using an Arduino Uno. All right. There's different brands. There's like SparkFun, Elegoo, but it's all the Arduino Uno ones. So make sure that's set to Arduino Uno. Different boards have different kind of settings, air quotes. So make sure it's the right one. Secondly, port. This will probably be different for each computer, but basically you'll want to set port to the one that the Arduino is on. You could have multiple, and it might not show which one the Arduino is on. In which case, you'll just have to pick one. If you get like a port error, you'll know it's the other one. That's kind of the only way you can tell. All right, so yeah. All right, so if everyone has those two things set up, then click on the arrow, the small little arrow icon in the top left corner. And it should upload. So you'll see a little bit of code run down at the bottom. And then take a look at the built-in LED on the Arduino. It should be blinking on and off every second. Let's just wait till everyone's done that. Yes, you got it. Working. What is it say? You don't have to. Persistence of human vision without. Yes. Alright, does anyone have the other UPS? Yeah, try Arduino ISP. Just another thing, the programmer should probably be on Arduino ISP. I've never really touched that. Does anyone not have their stuff blinking? Cool. Alright, so the code that does this, if everyone takes a look, who here is like not good at programming, or like doesn't think they're good at programming, or like doesn't like it at all? Okay, fair question. Who feels like they're iffy? Like, eh? about coding? Okay, cool. So, and the slide doesn't appear. I don't know why. Okay, cool. Fine. So if everyone takes a look at the code, so if you maximize that screen and look at your code, right? In the void setup method, right? There'll be one line. Pin mode, yes, pin mode, LED built-in, output. This basically says, okay, pin mode is setting up the pins, so anything that usually is in or out of the Arduino, you have to set up with pin mode, and you usually do it in the setup method. This is saying, okay, for the pin that is connected to the built-in LED for the Arduino, right? Create that as an output. So whenever I talk to it, I'm saying, hey, either output or stop outputting. I'm not going to register any input from it. There are ways to make a pin both, but that gets really complicated and things usually go wrong very fast, so it's best to keep it either input or output. And that's basically all that is there in the setup. So when we look at loop now, if you all look at your code, you'll see what's the exact name? Digital write. Okay, so digital write. This basically says, okay, I'm going to digitally tell this pin, hey, turn on. It's just the name of the function. So it's like, hey, turn on, LED built in, and it says hi. That means I'm going to turn it on. I'm going to turn it to a 1, whatever you want to call it. And then there's delay of 1,000. Now Arduino measures things in milliseconds, so that's 1 second. So that's just something that's built in, but that's measuring, so every second, right, it'll go on, wait a second, off, because the next line is digital write LED input, or LED building low. That means turn it off. And then you wait another second. So it's going to be on for a second, off for a second, on for a second, off for a second. And it's going to keep on doing that until it dies, the power goes off, you upload new code, something, right? So that was the first program. That's basically the hello world of Arduinos.